Right now, in every direction you could turn, up past the ceiling, down through the floor, out past the farthest star you have ever seen, there is an edge to the universe. It is real, and astronomers can tell you almost exactly how far away it lies. Nearly everyone pictures it the same way, as a wall, a barrier, a final surface made of some material, waiting at the end of an impossibly long journey. But when you ask the simplest question about it, the one a child asks first, what is that edge actually made of? Every answer that treats it as a wall quietly falls apart. It is not stone, it is not glass, it is not a curtain of nothing you could push a hand through, and strangest of all, it is not even out there ahead of you. A faint glow from that very edge is passing through your body at this exact moment, and it has been your whole life. So what is the edge of the universe made of, if it is not a wall? By the end of tonight, you will know exactly, and the answer is stranger and quieter and far more beautiful than any barrier could ever be. Get comfortable and hit subscribe if you're new here, because by the end of this, the word edge will never mean a wall to you again. Now, let's slowly ease into this. Part 1. The wall that isn't there. There is a question you almost certainly asked once, probably when you were young, lying awake in the dark or staring up at a night sky that felt a little too large. The question is simple. If you could climb into a ship and fly outward, straight and fast and forever, past the last planet, past the last star, past the very last stray atom drifting in the cold, what would you finally hit? Somewhere out there, surely, the universe has to stop. And when it stops, there has to be something at the stopping place. A wall, a barrier, an edge. And so the child's question, the one that has never really left any of us, arrives on its own and refuses to leave. What is the edge of the universe made of? You can feel how reasonable the question is. Every single thing you have ever encountered in your life has an edge, and every edge is made of something. The table has a rim of wood, the ocean has a shore of sand, the room you are sitting in has walls, and the walls are made of plaster and paint and brick. Your whole intuition, built over a lifetime among bounded things, tells you that a boundary is a place, and that a place is made of material. So when you imagine the boundary of everything, your mind reaches for the same answer it always uses. It pictures a surface. It pictures a substance. It wants to know whether the edge is stone or glass or metal, or whether it is a curtain of pure nothing that you could reach out and push your hand straight through. Tonight I want to take that question completely seriously, because it deserves to be taken seriously. And then I want to walk with you, slowly, toward an answer that is stranger and quieter and far more beautiful than any wall could ever be. And I should tell you at the start that the answer is not going to be a material at all. The edge of the universe is real. It is not a metaphor, and it is not a trick of language. Astronomers can tell you, tonight, exactly how far away it lies, in numbers they have measured with extraordinary care. But when you finally arrive at what that edge is made of, you will find that it is not built out of any stuff you could name. It is made out of two things you would never have guessed. And by the end of this you will understand both of them completely. Here is the first crack in the wall, the first hint that the picture you inherited as a child is going to come apart in your hands. The edge that we can actually point to, the boundary that real telescopes reach when they look as far as it is possible to look, is not made of matter. There is no shell of rock out there. There is no membrane, no fence, no final surface of solid material marking where everything ends. And yet there is genuinely something there, something we can see and measure and even photograph. The problem is not that the edge is empty. The problem is that the word edge has quietly misled you because it made you think of a boundary in space, when the real boundary is something else entirely. Think for a moment about what the word edge does to your imagination. When you picture the edge of a table, you picture a line you could stand beside, with the table on one side and the open air on the other. It is a boundary in space, a place with a here and a there, a this side and a that side. That is the picture nearly everyone carries into the question of the cosmos, and that is exactly the picture we are going to have to set down. Because the universe does have a boundary that we can find, and we can even tell you its distance in light years. But it is not a boundary in space, the way the shore is a boundary of the sea. It is a boundary in time, and a boundary in time behaves nothing like a wall. I know that sounds like wordplay, like I am dodging the question with a clever phrase, so let me make it concrete, because it is not wordplay at all. When you look out toward the so-called edge of the universe, you are not really looking across a great distance toward a barrier standing at the far end of space. You are looking backward. You are looking into the past. The farther out you turn your gaze, the further back in time you are actually seeing, and the edge is simply the earliest moment when there was anything at all to see. That is the whole secret, compressed into a single sentence, and the rest of tonight is going to be the slow unpacking of it, because that one sentence changes everything about what the edge is, where it is, and what it is made of. Hold on to the two words I keep circling, because they are the answer we are building toward, and I am going to withhold their full meaning until you have earned it. Light and time. By the time we are finished, you are going to see exactly why the edge of the universe is made of light and time and nothing else. Why that edge is arriving at you right now from every direction at once. Why you could fly toward it for 1 billion years and never reach it. And why the version of the edge that surrounds you is not even the same as the one surrounding someone in a distant galaxy. Each of those claims is going to sound impossible when I first say it, and each of them is going to feel obvious by the time we are done. Notice already how far we have drifted from the child's picture of a wall. The wall was supposed to be a fixed place, out there, made of some material, the same for everyone, waiting at the end of a long journey. And every single one of those assumptions is about to fall. The edge is not a fixed place. It is not out there, in the direction you are facing. It is not made of material. It is not the same for everyone, and it does not wait at the end of a journey, because no journey can ever reach it. 5 assumptions, 5 quiet collapses, and what is left standing at the end is something that no child, and honestly no adult, ever imagines when they first ask the question. Before we take that step, sit for a moment with how odd it is that a question this old still has no simple answer. People have asked, what lies at the end of everything, for as long as there have been people. The ancient Greeks imagined an outermost sphere, a crystal shell holding the stars, turning slowly above the world. Medieval maps of the heavens drew a hard boundary at the top and labeled what lay beyond it as the domain of the divine. Even the phrase we still use, the edge of the world, comes from a time when people believed you could sail far enough to fall off. Every one of those pictures was an attempt to put a material at the boundary, a shell, a dome, a lip you could tip over. And every one of them was wrong in the same way, for the same reason, a reason no one could have known until we learned how to read the light itself. The instinct to build a wall at the end of things is thousands of years old. Tonight we finally get to watch it dissolve. So let us not answer too quickly. Let us do what this question has always deserved and go the long way around, one careful step at a time, until the answer is not a fact I hand you, but a thing you can see for yourself. And the first step is the strangest doorway of all, because to understand what the edge is made of, we have to stop thinking about distance and start thinking about sight. We have to ask a question that sounds almost too simple to matter, and yet contains the entire mystery inside it. If you pointed the most powerful telescope ever built straight out into the dark, and you kept looking farther and farther and farther, what would you actually see at the very end? The answer is not a wall. The answer, as we are about to find, is a fog. Part 2. Looking out is looking back. Everything you have ever seen, you have seen late. This is the fact we have to start with, because it is the hinge the whole answer turns on, and yet almost no one carries it around in daily life. Light is fast, unimaginably fast by human standards, but it is not infinitely fast. It travels at about 300,000 kilometers every second, and not one bit faster. That speed is enormous, but it is a limit, and because it is a limit, every image that arrives at your eyes is a message from the past. When you look at anything at all, you are never seeing it as it is right now. You are seeing the light it sent out a little while ago, and you are seeing the thing as it was at the moment that light departed. For things close to you, the delay is so tiny that it might as well not exist. The light bouncing off your own hand reaches your eye in a few billionths of a second, so you see your hand essentially as it is. But stretch the distance out, and the delay grows with it, until it becomes impossible to ignore. The sun sits about 150 million kilometers away, and its light takes a little over 8 minutes to cross that gap. So you never see the sun as it is. You see the sun as it was 8 minutes ago. If it somehow blinked out of existence right now, you would carry on in full daylight for another 8 minutes, entirely unaware, because the news of its disappearance would still be on its way to you at the speed of light. Now let the distances become truly large, and watch what happens to time. The nearest star beyond the sun, a faint red point called Proxima Centauri, lies a little over 4 light-years away, which means its light takes more than 4 years to reach us. You do not see that star as it is tonight. You see it as it was 4 years ago. Look at a star 500 light-years off, and you are seeing light that left it 5 centuries ago, when the world below was a very different place. The star might have died in the time its light has been traveling, and you would have no way to know, because the message of its death has not yet arrived. Every night sky is a photograph of the past, with each point of light showing its source at a different, older moment. The sky is not a snapshot of now. It is a collage of many different thens. This is the tool that turns a telescope into something far stranger than a magnifying glass. A telescope does not just let you see things that are faint and far, it lets you see things that are old. Because distance and time are locked together by the fixed speed of light, to look farther out is automatically to look further back. The two directions, outward through space and backward through time, are not separate journeys. They are the same journey. A galaxy 1 billion light-years away is not just a billion light-years distant. It is a billion years into the past, shown to you as it was long before the Earth had complex life, its ancient light only now completing its crossing to land on a mirror we built to catch it. So imagine we do exactly that. Imagine we point our very best instrument out into the dark and begin, patiently, to look farther and farther, and watch how the universe changes as we go deeper. Close by, we see galaxies that look mature and settled, much like our own, because their light is relatively young. Push out farther, and the galaxies begin to look different, smaller and rougher and more chaotic, because we are now seeing them in their youth, before they had time to grow and calm and organize. Farther still, and the light from these objects has been stretched and reddened by its long journey through expanding space, until the galaxies glow a dark red, the color of great age and great distance layered together. We are not just traveling out, we are traveling down, into the early history of everything. Keep going, and something begins to happen that you might not expect. The galaxies start to thin out. This is not because we have reached the edge of where galaxies exist in space. It is because we have looked so far back in time that we are approaching the era before galaxies had finished forming, the cosmic dawn, when the first structures were only beginning to assemble out of the darkness. Our newest and most powerful telescopes have reached almost exactly this frontier. They have captured galaxies as they were within the first few 100 million years after the beginning, small and fierce and newborn, some so young and so far that their light has been traveling for more than 13 billion years to reach us. These are nearly the most distant objects it is possible to see, but they are still not the edge. Push past even them, back toward the very first few 100 million years, and you run out of galaxies altogether. You reach a time before any star had ignited, before the first galaxies had gathered themselves together, when the universe held no bright points at all. There is nothing there to see in the way we normally mean seeing, because there were no stars yet to shine. And this is the moment where the naive picture of a wall finally fails completely, because we have not arrived at a barrier standing in space. We have arrived at a time before there was any light from any object, and the question quietly changes shape. The question is no longer what lies at the far end of space. The question is, what is the earliest thing we can possibly see? It helps to picture what we are really doing as peeling an onion made of time. Each shell of sky we look through as we go farther out is a layer from an earlier chapter of the universe, and the layers are stacked in order, the youngest nearest and the oldest farthest. The Andromeda Galaxy, the nearest large neighbor to our own, is close enough that we see it as it was about 2.5 million years ago, when the first upright human ancestors were walking the Earth. A cluster of galaxies, 500 million light-years out, shows us a scene from before the dinosaurs. The reddened, chaotic little galaxies near the frontier show us the universe as a rowdy toddler. The great telescope now working above us, designed specifically to catch this most ancient light, has found galaxies whose light left them when the cosmos was only around 330 million years old, a tiny fraction of its present age. And the crucial point is that this ordering is not a choice or an accident. It is forced on us by the finite speed of light. You literally cannot look far without looking early. The depth of space is a recording of the history of time, and every telescope is a kind of time machine that only ever points backward. And here is where it becomes remarkable, because the answer is not darkness. You might expect that if you look back far enough, past the first stars, you would simply hit a blank, an empty black nothing, the screen going dark because there is nothing left to show. That is not what happens. When you look out to the very limit, past the last and youngest galaxies, into the era before any star existed, you do not find blackness. You find light, a specific, faint, uniform light that comes from every direction at once and fills the entire sky, a soft glow with no stars in it, older than any galaxy, older than any star, the most ancient light there is. It sits there at the boundary of everything we can see, like a fog closing off the far end of vision. That fog is the edge, and in the next part, we are going to walk right up to it and ask the only question that matters. What is it? Where did it come from? And why is the oldest thing in the universe still glowing, faintly, in every direction you could ever choose to look? Part 3. The oldest light. To understand the fog at the edge of sight, we have to go back to what the universe was like when it was very young, because the fog is not a thing that sits far away in space. It is a moment, frozen and glowing, and to understand it, you have to understand the moment. So let us go back, not to the very first instant, but to the universe as it was when it was only a few 100,000 years old. It was a completely different place then. There were no stars, no galaxies, no planets, no darkness of any kind. The entire cosmos was filled, evenly and everywhere, with a hot, dense, glowing gas, and that gas was so hot that ordinary atoms could not even hold themselves together. Think about what that means. An atom is a nucleus with electrons bound around it, held in place by electrical attraction. But if you heat matter enough, the electrons are torn loose and set free, and what you have left is not a gas of atoms, but a plasma, a soup of bare nuclei and free electrons all flying around independently. That is what the early universe was, everywhere, all at once. A plasma so hot it shone like the inside of a star, filling all of space with light. And that plasma had a property that turns out to be the whole key to the edge of the universe. It was opaque. You could not see through it. The reason it was opaque is subtle and worth slowing down on, because it explains everything that follows. Light travels freely through empty space and through neutral gas, but it cannot travel freely through a sea of free electrons. Free electrons are extraordinarily good at scattering light. A photon in that early plasma could not fly in a straight line for any real distance. It would travel a tiny way, slam into a free electron, ricochet off in a random new direction, travel another tiny way, hit another electron, and bounce again. Over and over, endlessly. The light was trapped, not because it was held still, but because it could never go anywhere in a straight line. It was like trying to see through a dense fog, where the light of a distant lamp is scattered so many times by the water droplets that it dissolves into a formless glow. The whole universe was that fog, bright, blinding, and impossible to see through. I want you to actually be there for a moment, because this is one of the strangest places you could ever stand, and it is a real place that really existed. Imagine you are floating inside the universe when it is 380,000 years old. There is no up and no down, no stars, no dark sky, nothing to fix your eyes on. In every direction, there is only a searing, uniform white-orange glow, brighter than standing inside a furnace, the same in front of you and behind you, and to every side. You cannot see your own hand held out in front of your face, not because it is dark, but because the light is scattering so violently off the electrons all around you that no clear image can form at all. There is no distance here, no horizon, no shape. There is only light, everywhere, pressing in from all sides, a fog of pure fire, with no edge and no center, filling the entirety of a young and formless cosmos. This is the universe before it could see. Now let the clock run forward, and watch the miracle happen, because it happens gradually, and then, in cosmic terms, all at once. The universe is expanding, and as it expands it cools, the way any gas cools as it spreads out. The searing plasma slowly drops in temperature, and at a certain point, when the temperature falls to somewhere around 3,000 degrees, something changes that changes everything. The plasma becomes cool enough that the electrons can finally be captured by the nuclei and held in place. Electrons and nuclei combine into complete, neutral atoms, mostly hydrogen and a little helium, and the free electrons, the ones that were scattering all that light, vanish from the scene because they are now locked inside atoms. The instant the free electrons are gone, the fog lifts. This is the pivotal moment in the entire story of the edge. So let me say exactly what happens. With no more free electrons to scatter it, the light that had been trapped and bouncing for hundreds of thousands of years is suddenly free to travel in straight lines. For the first time in the history of the universe, light can cross open space without being knocked off course. The cosmos, which had been a glowing, blinding fog since its birth, becomes transparent in a relatively brief window of time. The light is released, all of it, everywhere, at once, streaming outward in every direction through a universe that has just, for the first time, opened its eyes. That released light has a name, and the surface it came from has a name, and both names matter. Scientists call the moment the atoms formed recombination, which is a slightly misleading word, because the electrons and nuclei had never actually been combined before, but the name has stuck, and the sphere in the sky from which this final release of light is reaching us right now is called the surface of last scattering. That phrase is worth holding on to, because it is beautifully literal. It is the surface marking the last time this light was scattered by an electron, the last bounce, the moment each of these photons broke free and began the long, straight, uninterrupted journey that some of them are only finishing now, landing in our telescopes after more than 13 billion years in flight. And this is the thing at the edge. This is the fog we ran into at the end of part 2. It is not a wall of matter, it is a wall of light, the light of the entire universe at the instant it became transparent, the oldest light it is possible to see, coming to us from the boundary of the observable cosmos. When you look as far out as you can look, in any direction, you are looking back to this moment, and the surface of last scattering is what closes off your view. You cannot see past it with light, not because a barrier stands in the way, but because before that moment, there was no light that could travel freely to be seen. The edge of what we can see is the last scattering of the oldest light. It is worth being honest that this clearing did not happen in a single instant, the way flipping a switch would. Recombination took time, something like a few tens of thousands of years from beginning to end, as the temperature drifted down and more electrons were captured. So the surface of last scattering is not a razor-thin sheet. It is a band with a slight thickness to it, a few thousand light-years thick, a soft edge rather than a hard one, more like the way a morning fog does not vanish in a moment but thins over a stretch of minutes until, almost without your noticing, you can suddenly see the far side of the field. But on the scale of the whole cosmos, a band a few thousand light-years thick, sitting more than 40 billion light-years away, is astonishingly sharp. It is thin enough that we can treat it as a single surface, a single glowing skin wrapped around the sky, the last moment before the universe became clear. Astronomers sometimes call the image of it the baby picture of the universe, and the phrase is exactly right. It is a portrait of the cosmos taken at 380,000 years old, the earliest picture there will ever be, because there is nothing earlier that light can show. Every photograph of anything older is impossible, forever, because before this moment, the universe had its eyes closed. But there is a puzzle hiding in this, and you may already feel it. That light was released when the universe was 3,000 degrees, glowing like the surface of a dim star. If the edge of the universe is made of light that hot and that bright, why is the night sky dark? Why do we not see a blinding glow filling every direction, as bright as that ancient furnace? The universe should be on fire with it, and yet it is not. Something has happened to that light in the 13 billion years it has been traveling, something that has hidden it from our eyes while leaving it everywhere around us. In the next part, we are going to find out exactly what happened to the oldest light and where, at this very moment, it actually is. Part 4. The glow that fills the room. The answer to where the oldest light went is one of the most beautiful ideas in all of science, and it comes down to a single word: stretching. In the 13 billion years since that light was released, the universe has not been sitting still. It has been expanding, and as it expands, it stretches everything inside it, including the light traveling through it. A wave of light has a wavelength, a distance between its crests, and stretching space stretches that wavelength out longer and longer. Longer wavelengths mean cooler, dimmer, less energetic light. So the light that began as a searing white-orange glow, as hot as the surface of a dim star, has been stretched by the expansion of the universe by a factor of about 1100, cooled and dimmed, and shifted right out of the range your eyes can see. Where did it end up? It ended up in the microwaves, the same broad family of light your kitchen appliance uses, but far fainter and colder than anything that could warm your food. The oldest light in the universe now glows at a temperature of only about 2.7 degrees above absolute zero, the coldest temperature there is. It is still there, still arriving, still coming to us from that surface of last scattering in every direction, but it has been cooled so far by the stretching of space that it no longer shines in visible light. It shines in microwaves, too cold and too faint to see or feel. And that is why the night sky is dark. The fire of the early universe did not go out. It was stretched until it became invisible. This faded relic has a name. It is called the cosmic microwave background, and it is, quite literally, the edge of the observable universe, glowing at us from all sides. And here is the first genuinely strange thing about it, the thing that starts to pull the whole idea of an edge inside out. It does not come from one direction. It is not a patch of glow off in the distance that you could point at. It comes from every direction at once, filling the entire sky, the same above you and below you, and on every side, a bath of faint microwave light, in which the whole universe, and you, are completely immersed. It is not a wall over there. It is a glow all around. I want you to feel where this light is right now, because it is not a distant abstraction. It is here, in the room with you. Sit for a moment in the dark of wherever you are. All around you, passing through the walls as if they were not there, passing through the window and the roof and the empty air, this ancient light is streaming in from every direction. It is passing through your body at this very second, hundreds of millions of these microwave photons flooding through every cubic meter of the space you occupy, soaking through you, silently and continuously. You cannot see it or feel it because it is far too faint and far too cold, but it is here, a whisper of the newborn universe filling the room you are sitting in, the same in every direction, arriving without pause. The edge of the universe is not somewhere you would have to travel to reach. It is falling on you now, and it always has been. Let that settle for a moment, because there is something in it worth holding. The light landing on your skin tonight, the light passing through the very space your body takes up, left its source more than 13 billion years ago. It began its journey before there were atoms clumped into anything, before the first star had ever ignited, before there was a single galaxy anywhere in existence. There was no Earth, no sun, no solid object of any kind in the whole cosmos when this light set out. It has been traveling in a straight line, across an expanding universe, for the entire age of everything, and its journey ends here, tonight, in your eyes and on your skin. Of all the places it could have finished a 13 billion year flight, it finishes some of it in you. The oldest thing you will ever encounter is not in a museum. It is the glow you are sitting inside of right now. The story of how we found this light is almost too fitting to be true. In 1965, two scientists named Arno Penzias and Robert Wilson were working with a large horn-shaped antenna in New Jersey, trying to make careful radio measurements of the sky. But they kept picking up a faint, persistent hiss, a background noise they could not get rid of, coming from every direction they pointed the antenna, at every hour of the day, in every season. They checked their equipment obsessively. They suspected a fault. They even found that pigeons had been roosting inside the antenna and leaving droppings, so they cleaned the whole thing out and evicted the birds. The hiss remained. No matter what they did, this uniform whisper of microwave noise would not go away, and it seemed to be coming from the sky itself. What they did not know, at first, was that only a short distance away, a group of physicists at Princeton, led by Robert Dicke, had been working out that if the universe had begun in a hot, dense state, it should be filled today with exactly this kind of relic radiation, cooled by expansion to a few degrees above absolute zero, and they were building an instrument to search for it. When the two groups learned of each other, the pieces fell into place at once. Penzias and Wilson had stumbled, by accident, onto the faded fire of the early universe, the very glow the theorists were preparing to hunt for. The hiss they could not remove was the edge of the observable cosmos. They received the Nobel Prize for it, and the idea had in fact been anticipated even earlier, in the late 1940s, by George Gamow and his colleagues Ralph Alpher and Robert Herman, who predicted a relic radiation of a few degrees before anyone had the tools to look. There is a small, wonderful detail that brings this light out of the laboratory and into ordinary life. If you are old enough to remember analog television sets, the ones that showed a storm of black and white static when they were tuned between channels, then you have already seen this light with your own eyes. A small fraction of that dancing snow on the screen was the cosmic microwave background, the antenna catching the faint microwave glow of the early universe mixed in with earthly signals. The edge of the universe was, for decades, sitting quietly in living rooms, dismissed as nothing but noise. People stared right at the oldest light there is and thought their reception was bad. When scientists finally studied this glow with dedicated instruments in space, they found something that sealed the case beyond any doubt. The light has the most perfect thermal spectrum ever measured anywhere in nature. The exact glow of an object at a single temperature, precisely what you would expect from the cooled fire of a hot early universe, and nothing else. And it is smooth to an almost unbelievable degree. If you measure its temperature in one direction and then in the opposite direction, the two numbers agree to, within about 1 part in 100,000. The whole sky is the same faint glow, to that precision everywhere. There are tiny ripples in it, differences of 100,000th of a degree from place to place, and those ripples turn out to be the seeds from which every galaxy later grew, a fact we will come back to. But the headline is the smoothness. The edge of the universe is the most uniform thing we have ever found, a bath of light, so even that, for a long time, our instruments could not detect any variation in it at all. There are, by the way, more of these ancient photons in every cubic meter of space than there are atoms in enormous stretches of the cosmos. The universe is far more full of this old light than it is of matter. So now we know what the fog at the edge is made of. It is light, the oldest light, released at the surface of last scattering, and stretched by expansion into a cold microwave glow that fills all of space. That already overturns the child's picture of a wall, but it raises a question that is even stranger, and it is the question that finally breaks the idea of an edge as a place. If this light is coming at us equally from every single direction, filling the whole sky, surrounding us completely on all sides, then where exactly is the edge? Because a glow that comes from everywhere at once is not a wall standing out there in front of us. It is a shell wrapped all the way around us. And in the next part, we are going to ask the question that shell forces on us, the question that moves the edge from something far away to something you are standing in the very middle of. Part 5. A wall you are standing in the middle of. Let us take the strange fact from the last part completely seriously, because taking it seriously is what finally breaks the idea of an edge as a place. The oldest light reaches us equally from every direction. Point your instrument at the sky above, and there it is. Point it at the ground beneath your feet, through the whole earth, and out the other side, and there it is again, the same glow, the same temperature, the same faint microwave whisper. Turn in a full circle, tilt up, tilt down, and the edge of the universe is there in every direction you choose, always at the same enormous distance, always the same. This is not how a wall behaves. A wall is in one direction. This is something else. This is a wall you are standing in the middle of. Sit with that phrase, because it is going to matter for the rest of the night. A wall you are standing in the middle of. It sounds like a contradiction, because walls, in ordinary life, are never something you are inside of, but the surface of last scattering is exactly that. It is a sphere, and you are at its center, and it surrounds you completely, the same distance away, no matter which way you look. The edge of the observable universe is not a boundary at the far end of your vision. It is a spherical shell drawn all the way around you, with you sitting precisely in the middle of it. Now, the moment you hear that, a very old and very tempting idea starts to whisper. If the edge of the universe is a perfect sphere centered on me, then surely I must be at the center of the universe. Surely this is proof that our position is special, that we sit at the very middle of everything, with the cosmos arranged in neat shells around us. It is a natural thought, and it is completely wrong, and understanding why it is wrong is one of the most important steps in this entire journey. The reason it is wrong is that everyone, everywhere, sees exactly the same thing. Imagine a civilization in a galaxy billions of light years away from us, in some direction, near what we would call the edge of our observable universe. When they look out at their sky, what do they see? They see the oldest light reaching them from every direction, a surface of last scattering surrounding them, a sphere centered on them, at the same enormous distance in every direction they look. They are just as convinced that they are at the center of everything as you might be, and they are just as wrong and just as right as you are. Every observer, everywhere in the universe, sits at the center of their own observable sphere, not because they are special, but because of how the light works. Here is why this happens, and it is beautifully simple once you see it. Every observer has been receiving light for the same amount of time, the age of the universe, and light travels at the same speed for everyone. So every observer can see out to the same distance in every direction, a sphere of the same radius, centered on themselves. It is exactly like standing in an open field on a foggy day. The fog closes off your view at the same distance in every direction, so you stand at the center of a circle of visibility, a circle of foggy edge all around you. Walk to another spot in the field, and you are still at the center of your own circle, the same size, moving with you. The center of the circle is not a special place in the field. It is just wherever you happen to be standing. The universe is the same. Everyone is at the center of their own sphere of sight, and no one is at the center of the universe, because the universe has no center at all. And this leads to something about the beginning that almost everyone gets wrong, so let me state it clearly. The event we call the Big Bang was not an explosion at a point in space, a single location from which everything flew outward, leaving a center behind. The Big Bang happened everywhere at once. Every point in the universe, including the exact spot where you are sitting, was part of that early, hot, dense state. The plasma that released the oldest light was not off in one corner of space. It was everywhere, including right here, in the space your body now occupies. The reason we see the surface of last scattering far away, in every direction, is that we are seeing the light from the parts of that everywhere plasma that were far enough away for their light to take the whole age of the universe to reach us. The near parts of the plasma that was right here, released their light long ago, and it swept past us billions of years back. What we see now is only the light from the shell at just the right distance, the distance whose light is arriving today. Think about what that means for the edge. The edge is not a location that exists out there independently of you, sitting at some fixed address in the cosmos that everyone could agree on. The edge is drawn around you, by your own position and by the finite time light has had to travel toward you specifically. Someone standing where that distant galaxy is has a different edge, centered on them, extending billions of light years past yours in the direction away from us, and falling billions of light years short of yours in the direction toward us. Your edge and their edge are different spheres, overlapping but not the same. There is no single true edge that belongs to the universe itself. There are only observers, each carrying their own edge with them, each at the center of their own sphere of ancient light. There is an old and useful way to picture a universe with no center, and it is worth a moment because it makes the strangeness feel natural. Imagine a lump of dough with raisins scattered through it, rising in a warm oven. As the dough swells, every raisin moves away from every other raisin, because the dough between them is growing everywhere at once. Sit on any raisin you like and look around, and you will see all the other raisins receding from you, and you will feel as though you are at the center of the expansion. But every other raisin sees exactly the same thing from its own position. There is no special raisin. There is no center to the rising. The expansion is happening between all of them, everywhere, at the same time. The universe expands like the dough, not like an explosion, with a center and an outside. And if you want to imagine a version with no edge at all, picture the raisins painted on the surface of a balloon being inflated. Every point moves away from every other. Every point is equally a center, and nowhere on that surface is there an edge or a middle. Asking where the center of the universe is turns out to be like asking where the center of the surface of a balloon is. The question sounds sensible until you look closely, and then it quietly has no answer. We have now overturned 3 of the child's 5 assumptions. The edge is not made of material. We saw that already. The edge is not the same for everyone. We have just seen that. And the edge is not out there in one direction, because it wraps all the way around you. What remains is a genuine mystery about the size of this sphere, one that has been sitting quietly under everything we have said, and it is time to face it. That surface of last scattering, that shell of oldest light around you, is astonishingly far away. The light took more than 13 billion years to arrive, and yet the actual distance to that shell right now is not 13 billion light years. It is far larger, more than 40 billion light years, 3 times farther than the light could have traveled in the whole age of the universe. That should sound impossible. How can the edge be 40 billion light years away when the light has only had 13 billion years to travel? In the next part, we solve that puzzle, and the solution is the second ingredient of the answer we have been building toward all along. Part 6. Farther than light could travel. The puzzle we ended on sounds like a contradiction, and the way it resolves is the second great ingredient of the whole answer. The oldest light has been traveling for about 13 billion years. Light covers 1 light year of distance in 1 year. So you would think the source of that light must be about 13 billion light years away, and no farther. And yet astronomers tell us the surface of last scattering is now more than 46 billion light years away, more than 3 times farther than the light could possibly have traveled in the time available. Either the numbers are wrong, or something is happening that our everyday intuition does not include. And what is happening is the expansion of space itself. Here is the key idea, and it is the thing that intuition almost always leaves out. When we say the universe is expanding, we do not mean that galaxies are flying apart through space, like debris from a blast, into some pre-existing emptiness. We mean that space itself is growing. New distance is being created everywhere, all the time, between all things. The galaxies are not so much moving through space as being carried apart by the swelling of the space between them. And this changes everything about how far light can get. Because while the light is traveling across space, the space it has already crossed keeps growing behind it, and the space still ahead of it grows too. Let me make this concrete with the light itself, because it is worth following 1 photon on its journey. A photon leaves the surface of last scattering, from some patch of that early plasma, and sets off toward the place that will one day become our galaxy. When it begins, that patch of plasma is actually fairly close to us in the young, small universe, only around 40 million light years away. The photon starts crossing that gap, but as it travels, space expands, and the ground it is covering stretches out beneath it, and the patch it came from is carried ever farther behind. For more than 13 billion years the photon flies, and the whole time the universe is swelling around it, adding distance faster than the photon can eat into it in the early going, then gradually letting the photon gain. By the time the photon finally lands in our telescope, the patch of plasma that released it, carried along by all that expansion, is now more than 46 billion light years away. I want you to ride along with that photon for a moment, because it is one of the most extraordinary journeys there is. Picture yourself as that single speck of ancient light, breaking free at the instant the fog lifts. Around you, at first, the universe is young and dense and close. You fly outward in a straight line, and the space beneath you begins to stretch, gently at first, then relentlessly. Galaxies form out of the darkness as you pass, wheel slowly through their lives, and fall behind you. Stars ignite and die in the distance. Whole ages of cosmic history unroll around your path, and still you fly, straight and steady, never speeding up, never slowing down, while the road behind you grows longer than any road has a right to be. The place you came from drifts farther and farther away, not because it is fleeing, but because the space between you and it keeps being born. And after 13 billion years of this, you strike a mirror on a small blue world, and your journey ends, and the patch of fire that launched you is now unthinkably far behind, stretched away by the growth of everything. So there are really two different distances to the edge, and both are true, and they answer different questions. There is the distance the light traveled, which is tied to how long it was in flight, about 13 billion light years. And there is the distance to where that source sits right now, today, after all the expansion, which is more than 46 billion light years. Neither number is wrong. They are answers to two different questions. How far did the light come, and how far away is its source at this moment? The full observable universe, measured the second way, is a sphere about 46 billion light years in radius, which makes it about 93 billion light years across, even though the universe is only about 13 billion years old. That is not a paradox. It is the direct signature of expanding space. There is one more consequence of this, and it is the part that most shocks people when they first meet it. If space itself can grow, and grow everywhere at once, then the distance between us and a sufficiently far-away galaxy can grow faster than light. The most distant regions we can see are receding from us faster than the speed of light, right now. And this does not break any law of physics, because nothing is moving through space faster than light. The galaxies are sitting more or less still in their own patches of space. It is the space between us and them that is expanding, and there is no speed limit on the growth of space. The cosmic speed limit applies to objects moving through space, not to space itself stretching, so the edge of the universe is receding from us faster than light can travel, which is one more reason it is not a wall you could ever drive up to. It is running away from you faster than any signal could chase it. There is a lovely puzzle tucked inside all this that physicists like to pose. If the source of the oldest light is now receding from us faster than light, and it was receding faster than light for much of the journey, how did the light ever manage to reach us at all? The answer is one of the most counterintuitive, true things in cosmology. Picture an ant walking along a rubber band toward your hand, while someone stretches the band. If the band stretches fast enough, the ant can actually be carried backward, losing ground even as it walks forward, the far end getting farther away. And yet, if the stretching slows down over time, the ant can eventually start making progress, cross the remaining distance, and arrive. The oldest light is that ant. For a long time it was losing ground, carried backward by the ferocious early expansion, even as it flew toward us. But the expansion eased, the light began to gain, and after billions of years of struggle, it finally crossed the last stretch and reached us. Some of the light we see today spent much of its life moving farther from us before it ever got closer. The photon did not travel a simple straight road of fixed length. It traveled a road that was being rebuilt, longer and then shorter, the whole way. It is worth pausing on the sheer size of what this sphere contains. Inside that shell of oldest light, 46 billion light years in every direction, lies everything we can ever observe, on the order of hundreds of billions of galaxies, perhaps as many as 2 trillion by some counts, each with its own hundreds of billions of stars, all of it packed inside the bubble, bounded by the surface of last scattering, and every bit of it is enclosed not by a wall of anything, but by that boundary of light and time. The container of the entire visible universe is not a shell of material. It is a moment, wrapped around us, at a distance set by how long light has had to run. And now the shape of the real answer is coming into focus. The edge is not made of matter, it is made of light. It is not the same for everyone, it wraps around each observer, and its distance is not set by any material barrier, but by the age of the universe and the growth of space. The two of them together, deciding how far the oldest light could get before reaching us. That is already the beginning of the phrase I promised you at the start, that the edge is made of light and time. But there is a subtlety we have skipped past. I have been speaking as if there is one edge, one boundary, one sphere. In truth, there is more than one. There are several different boundaries out there, several different kinds of edge, each defined in a different way, and they sit at different distances and do different things. Understanding the difference between them is the next step, and it is the step that reveals why one of these edges is quietly, permanently closing, carrying pieces of the universe out of our reach forever. Because you cannot travel to the edge, we have seen. But it is stranger than that. Some of the universe is traveling away from the edge and will never be seen again. Part 7. The Three Edges. Before we go any further, let us stop and put the pieces together, because we have gathered a lot of them, and this is the natural place to lay them side by side. We began with a child's picture of a wall at the end of space, made of some material, the same for everyone, waiting to be reached. We have replaced almost all of it. The edge we can see is made of light, the oldest light, released when the universe turned transparent. That light reaches us from every direction, so the edge is a shell wrapped around us, not a wall in front of us. Every observer sits at the center of their own shell, so the edge is personal, not universal, and the shell sits more than 46 billion light-years away, carried out there by the expansion of space, far beyond where light alone could have traveled. That is where we stand. Now we add the last structural piece, which is that there is not just one edge out there. There are several, and they are different, and the differences are the whole story of what happens next. The first edge is the one we have been talking about, and it has a proper name, the particle horizon. The particle horizon is the boundary of everything we could possibly have received any signal from since the beginning of the universe. It marks the greatest distance from which light, or anything else traveling at light speed, has had time to reach us in the whole age of the cosmos. This is the true outer edge of the observable universe, the sphere about 46 billion light-years in radius. The surface of last scattering, the wall of oldest light, sits just inside it, because the oldest light we can actually catch was released a few 100,000 years after the beginning, not at the very first instant. The particle horizon is the ultimate limit of what has had time to be seen. The second edge is a subtler one, and it trips people up, so let us go slowly. It is called the Hubble sphere, and it is the distance at which the expansion of space carries galaxies away from us at exactly the speed of light. Inside the Hubble sphere, galaxies recede slower than light. Outside it, they recede faster than light. You might think that the Hubble sphere is therefore the edge of what we can see, that anything receding faster than light must be invisible to us. But that is not true, and the reason is the ant on the rubber band from the last part. Light from galaxies beyond the Hubble sphere, the galaxies currently receding faster than light, can still reach us, because the expansion changes over time, and the light can still make progress across the stretching space. So the Hubble sphere sits at about 14 billion light-years, well inside the particle horizon, and we routinely see galaxies far beyond it. It is a real boundary, but it is not the edge of vision. It is the line between slower than light and faster than light recession, and light can cross it. The third edge is the most haunting of the three, and it is the one that changes the mood of this whole story, because it is about the future rather than the past. It is called the cosmic event horizon. The event horizon is the boundary set by this question. If we send out a beam of light right now, from this moment, how far can it ever get? And the answer, because of something we have not yet discussed, is that it can only ever reach so far, and no farther. There is a maximum distance from which light emitted today can ever reach us, and a maximum distance our own signals could ever reach. That distance is about 16 billion light-years. Anything beyond the cosmic event horizon is beyond our reach forever. From this moment onward, we can still see it, because its old light is still arriving, but we can never again touch it, never send anything to it, never receive anything it emits from now on. It has passed out of causal contact with us for good. Why should there be such a boundary at all? The reason is the same thing that stretched the oldest light into invisibility, and it is the great uninvited guest of modern cosmology. The expansion of the universe is not slowing down, it is speeding up. Something, which we call dark energy for lack of a better name, is causing the growth of space to accelerate. And in an accelerating universe, the distances between things grow faster and faster, until galaxies that are far enough away are being swept apart from us so quickly that no signal we send can ever catch up to them, and no signal they send after a certain point can ever catch up to us. The accelerating expansion draws a line around us, the event horizon, and everything past that line is drifting permanently beyond our future reach. Now notice what all three of these edges have in common, because it is the point of laying them out together. Not one of them is a wall, not one of them is made of any material. The particle horizon is set by the age of the universe and the speed of light. The Hubble sphere is set by the rate of expansion and the speed of light. The event horizon is set by the acceleration of expansion and the speed of light. Every single one of these boundaries is made of exactly two ingredients, and they are the same two ingredients every time: time and the finite speed at which things can travel or signal. There is no fourth edge made of stone waiting behind them. The universe draws its boundaries with clocks and speed limits, never with substance. Every edge is a horizon, and a horizon is not a thing. It is a limit of contact. It helps to feel how odd the faster-than-light recession really is, because people hear it and assume a rule is being broken. No galaxy anywhere is racing through space faster than light. If you stood next to any of those distant galaxies, you would find it sitting quietly in its own patch of space, its neighbors drifting only slowly nearby, everything perfectly obeying the cosmic speed limit locally. The enormous recession speed we measure is not any single galaxy's motion. It is the sum of a little bit of stretching added up across an enormous number of stretches of space between us and them. Each small piece of space grows only gently, but there are so many pieces stacked between us and a distant galaxy that the total, added all the way along, exceeds the speed of light. It is not a fast object. It is a great number of slow stretches, and the law that forbids fast objects says nothing at all about that. It is also worth being clear about how these three edges nest, because the ordering matters. The Hubble sphere is the smallest, at about 14 billion light-years, the line where recession reaches light speed. The event horizon is a little larger, at about 16 billion light-years, the limit of what we could ever reach or be reached by from now on. And the particle horizon is by far the largest, at more than 46 billion light-years, the full extent of what we can see. So there is a strange middle zone between the event horizon and the particle horizon, full of galaxies we can still see tonight, but can never again affect or hear from after this moment. We are watching their past, while their present has already slipped beyond our reach forever. Their old light still arrives, a portrait of how they were, while the galaxies themselves have already sailed out of the part of the universe we will ever be able to touch. It is a little like receiving letters from someone who has already moved somewhere you can never follow. And this is where the story stops being purely wondrous and picks up a thread of something quieter and sadder, because these edges are not fixed, they move. The particle horizon grows with every passing year, as light from farther and farther away finally reaches us. So in one sense, our window on the universe is always opening wider. But the event horizon, driven by the accelerating expansion, is doing the opposite. It is carrying galaxies out of our reach, one by one, forever. The edge is expanding and closing at the same time, in two different senses, and the closing one is winning in the long run. In the next part, we follow that closing edge to its conclusion, and we find out what it means that the sky itself is slowly, silently emptying, and why the fact that we can see anything at all tonight is a kind of luck we do not usually think to be grateful for. Part 8. The Edge That Is Also Loss. We tend to think of the universe as permanent, as a fixed backdrop that was here before us and will be here after us, unchanging in its broad shape. But the accelerating expansion means that is not true, not on the largest scale. The sky is slowly emptying, galaxy by galaxy, over spans of time far longer than the universe has yet existed. The accelerating growth of space is carrying other galaxies across our event horizon and out of our reach, first out of contact, and eventually out of sight altogether. The universe we can observe is not a stable inheritance. It is a slowly closing window, and we happen to be looking through it early, while it is still wide. Let us follow a single distant galaxy to its end, so this stops being an abstraction. Somewhere out near the edge of what we can see, there is a galaxy, an ordinary spiral, full of stars and worlds, drifting in the current of the expansion. As the eons pass, the space between us and it grows faster and faster. Watch its light as this happens. The light it sends us stretches, its color sliding toward the red, growing dimmer with each passing age. The galaxy seems to slow, its motions smearing out as the stretching lengthens every signal. Its light reddens and reddens further, sliding out of visible colors into the infrared, then into microwaves, then into faint radio, growing weaker the whole way. And then, at last, comes the final photon, the last particle of light that will ever reach us from that galaxy, the one emitted just before the galaxy crossed the point of no return. It arrives, stretched and faint, and after it, nothing. The galaxy is still out there, still full of stars, but no more of its light will ever cross the gap to us. It has slipped behind the event horizon, and it is gone from our sky forever. Not destroyed, just placed permanently out of reach. Now multiply that by every galaxy beyond a certain distance, and run the clock forward far enough, and you arrive at one of the loneliest facts in all of science. In the far future, hundreds of billions of years from now, an observer in our region of space will look out and see almost nothing. The accelerating expansion will have carried every galaxy outside our own local group beyond the horizon, their light stretched away into undetectable faintness. Even the oldest light, the cosmic microwave background, the very edge we have been studying tonight, will have been stretched so far by then that it will be undetectable, diluted past any instrument's ability to find it. The edge will have swallowed itself. A future astronomer, doing careful science with good telescopes, would conclude that the universe consisted of a single island of stars surrounded by infinite empty darkness, with no evidence that anything else had ever existed. The entire history we can read tonight would be gone, erased not by any catastrophe, but simply by the quiet, relentless growth of space. Sit with that for a moment, because there is something in it that is worth feeling rather than just knowing. We are alive at a readable moment. Right now, tonight, the edge of the universe still carries its message. The oldest light still reaches us. The distant galaxies are still visible. The evidence of the beginning is still written across the sky, in a language we have only recently learned to read. But this is a temporary condition. The window is closing, slowly by human measure but certainly, and there will come a time when no observer anywhere can look up and reconstruct the story we can reconstruct tonight. The universe is handing out this knowledge for a limited time only. We did not arrive too late to see the edge. We arrived, by an accident of cosmic timing, at almost the last good moment to see it clearly, before expansion begins to draw the curtains. Every person who has ever looked at the cosmic microwave background and understood what it is, belongs to a narrow window of watchers, in a universe that will spend most of its future unable to see its own past. There is a strange comfort folded into that, if you look for it. The fact that the edge is closing is exactly the same fact as the edge being made of time rather than material. A wall of stone would stand there forever, indifferent, always reachable in principle. But an edge made of light and time is a living, changing thing, tied to the age of the universe and the growth of space, and because it is made of those things, it moves as they move. Its impermanence is not a flaw in the idea, it is proof of what the idea is. The edge fades because it was never a substance, it fades because it is the past, and the past can be carried away. It is worth being precise about what survives and what does not, because the news is not all loss, not everything is carried away. Our own galaxy and its close companions, the couple of dozen galaxies gravitationally bound to us in what astronomers call the local group, are held together by their own gravity far more strongly than the gentle expansion can pull them apart. Gravity, on this small scale, wins, so that little cluster of galaxies will stay together. In fact, the Milky Way and its large neighbor Andromeda are drifting toward each other and will, over the next several billion years, collide and merge into a single enormous galaxy. Over much longer spans, the whole local group will fold together into one great island of stars. That island will remain, bound and intact, an oasis. But it will be an oasis in an apparently empty sea, because everything beyond it will have receded past the horizon. What is lost is not our neighborhood. What is lost is not our neighborhood. What is lost is not our neighborhood. There is a sharper edge to this loss that most people never hear, and it concerns not seeing, but reaching. Of all the galaxies we can currently observe, the great majority are already unreachable, even in principle, even by a ship traveling at nearly the speed of light launched today. The expansion has already carried them so far, and is accelerating them away so relentlessly that no craft we could ever build could catch them. Only a small fraction of the galaxies visible in our telescopes could ever, even in the most generous imagining, be reached by anything setting out from Earth now. The rest we can see, but never touch. Their light reaches us, a report from their past, while the galaxies themselves have already crossed into a part of the universe that is closed to us for good. We are looking at a sky that is, in large part, already a museum of the unreachable, beautiful images of places that no longer belong to our future in any sense. And the timescale, while enormous, is not infinite. Over the next 100 billion years or so, the sky as we know it fades. The distant galaxies redden and vanish, one after another. Eventually, even the cosmic microwave background, that faint bath of oldest light we spent tonight coming to understand, is stretched to wavelengths so long and so weak that no possible instrument could register it. The edge of the universe, which is glowing softly all around us tonight, will simply be gone, not moved, not destroyed, just stretched out of existence as a detectable thing. And any minds that exist then, in that far and quiet future, will have no way to know that a beginning ever happened, or that the universe was once full of galaxies, or that there was ever such a thing as an edge to see. We have now taken the edge apart almost completely. We know it is made of light. We know it wraps around each observer. We know its distance comes from the age of the universe and the expansion of space. And we know it is slowly closing, because it is made of time and not of matter. But there is one question left that we keep circling and have not yet answered directly. The question a child asks first, and we have saved for nearly last. If the edge is not a wall, then what is on the other side of it? What lies beyond the surface of last scattering, past the boundary of everything we can see? Is there anything out there at all? In the next part, we finally step past the edge and ask what, if anything, is on the far side. Part 9. what is actually on the other side. So we come at last to the question the whole thing started with, the one a child asks in the first breath. What is on the other side of the edge? If you could somehow pass through the surface of last scattering, if you could stand at the boundary of the observable universe and look outward, past it, what would you find? And now, having built up everything we have built, we can finally give the honest answer, which is not a wall, not an ending, and not a void. On the other side of the edge is more universe, simply more of the same, more space, more galaxies, more stars, stretching on beyond our sight, almost certainly for a very long way, and quite possibly forever. To see why, remember what kind of edge this is. It is a horizon, and the perfect everyday example of a horizon is the one you have seen 1,000 times, the horizon at sea. Stand on a ship, in the middle of the ocean, and look out, and you see a circle of water ending at a sharp line, the horizon, beyond which you cannot see. That line is real. You can measure how far away it is. It depends on how high your eyes are, and on the curve of the earth. But no sailor has ever believed that the ocean ends at the horizon, that there is a wall of water standing there, or that the sea simply stops. The horizon is not the edge of the ocean. It is the edge of your view of the ocean. Beyond it there is more sea, exactly like the sea around you, hidden only because the curve of the earth blocks your line of sight. And if you sail toward it, the horizon retreats, and new water comes into view, and you never reach a boundary, because there was never a boundary there to reach. The edge of the observable universe is that horizon, with time playing the role that the curve of the earth plays for the sailor. Our view is blocked, not by the curve of the earth, but by the finite age of the universe, by the simple fact that light from farther out has not had time to reach us yet. Beyond that horizon is more universe, just like ours, hidden only because its light has not arrived. The surface of last scattering is not the edge of the cosmos. It is the edge of our view of the cosmos. And in this one respect, the cosmic horizon is even gentler than the sea horizon, because the sailor can at least sail toward theirs, while we cannot sail into the past. The one thing we cannot do is uncover the hidden universe by traveling to it, because it is hidden behind a wall of time, and no ship travels through time in the needed direction. How do we know there is really more out there, and not some genuine edge just past where we can see? We know it from the character of the universe we can see. Look at the observable universe on the largest scales, and it is remarkably uniform. Galaxies are spread through it evenly, in every direction, with the same kinds of structures, and the same overall density wherever you look. The oldest light is the same temperature on every side of the sky, to 1 part in 100,000. There is nothing about our surroundings that looks like the neighborhood of an edge. When you approach the edge of a real thing, a forest or a city or a lake, you can tell, because things thin out and change near the boundary. The universe shows no such thinning, no such change, no hint that we are anywhere near a special place. It looks the same all the way out to the limit of our sight, which is exactly what you would expect if the limit of our sight is not a real boundary, but only the limit of how far light has traveled. This uniformity is so central that scientists have given it a name and made it a principle. They call it the cosmological principle, the idea that the universe is broadly the same everywhere and in every direction, that there is no special place, no center, no edge, no favored spot. It is not a law we can prove with certainty, but it is supported by everything we observe, and it is the natural reading of a cosmos that looks identical in all directions to the limits of vision. And if the cosmological principle holds, then the region beyond our horizon is filled with galaxies indistinguishable from the ones around us, arranged in the same web, obeying the same laws, going about the same business, none of them aware of being outside anyone's edge, because from where they sit, they are at the center of their own sphere, and we are the ones out beyond their horizon. Then there is the deepest version of the question. Not just is there more universe past the edge, but does the universe go on forever? Here we reach the limit of what we can know for certain, but the evidence leans in a clear direction. The geometry of space, measured with great care from the oldest light and from the arrangement of galaxies, appears to be flat to within a very small margin of error. And a flat universe, if that flatness continues beyond our horizon, as everything suggests it does, is spatially infinite. It has no edge as a place, no outer boundary, no farthest galaxy, no wall anywhere in any direction. In that picture, our observable universe, that sphere 93 billion light-years across, is a finite bubble of visibility inside a cosmos with no boundary at all, and every point in that endless cosmos has its own bubble, its own horizon, its own edge of light and time, and none of those edges is the edge of anything real. You might reasonably ask how anyone could measure the shape of all of space, and the method is elegant enough to be worth a moment. In the oldest light, there are faint ripples, hot and cold patches of a very particular characteristic size, frozen into the surface of last scattering by sound waves that rang through the early plasma. We know, from the physics of that early era, how large those patches actually were when the light was released, and we can measure how large they appear to us across the sky. Comparing the true size to the apparent size is like knowing the real height of a distant person and measuring how tall they look, which tells you how far away they are, and, crucially, whether the space the light crossed was flat or curved. If space were curved, the patches would appear systematically larger or smaller than their true size, because curved space bends the paths of the light like a lens. When the measurement is done, the patches appear at exactly the size that flat space predicts, to within a very small margin. Space, as far as we can measure it, is flat, and flat space, continued outward, does not close up into a ball or curve back on itself. It goes on. That single measurement of ripples in the oldest light is one of our strongest reasons to believe the universe extends far beyond the edge we can see, most likely without end. There is a subtler possibility that physicists take seriously, which is that the universe might be finite and yet still have no edge, the way the surface of a ball is finite in area but has no boundary anywhere on it. Such a universe would wrap around on itself, so that traveling far enough in a straight line would eventually bring you back to where you started, never crossing any wall. We have looked for the telltale signs of such a wrapping, repeated patterns that would show up in the oldest light, and we have found none, which means if the universe does wrap, it wraps on a scale larger than everything we can see. But notice that even in this case, the answer to the child's question is the same. There is still no wall. There is still no material edge. Whether the universe is truly endless or quietly folds back on itself, the only edge is the horizon of light and time, and beyond it is more cosmos, indifferent to any boundary. And that raises the last question of the night, about the edge itself, because we have been speaking as though the oldest light is the final wall, the deepest boundary there is, but it is not. There are older walls behind it, made of things that are not light at all, and in the next part we go looking for them. Part 10. The walls behind the wall. We have called the oldest light the edge, and in one important sense it is. It is the farthest thing we can see with light, the boundary of the visible universe, the surface beyond which no telescope of any kind can ever look, because before that moment, the universe was an opaque fog. But there is a hidden assumption buried in that sentence, and it is time to dig it out. The oldest light is the edge of what we can see with light. It is not the edge of what happened. Behind the wall of light, in the first few 100,000 years, an enormous amount of history unfolded. History that the wall of light hides from us completely. And the remarkable thing is that light is not the only messenger the early universe sent. There are older messengers, released before the fog ever lifted, and each of them is a wall of its own, deeper and earlier than the light. They are simply much harder to catch. To understand why there could be anything older than the oldest light, remember why light was trapped in the first place. Light was trapped because it scattered off the free electrons in the plasma, so it could not travel freely until those electrons were locked into atoms 380,000 years in. But not everything interacts with electrons. There are particles that barely notice ordinary matter at all, that pass through it as if it were not there, and those particles were free to travel long before the light was, released from much earlier and much hotter moments. If we could catch them, they would show us the universe as it was not at 380,000 years old, but at 1 second old, or even younger. They would be walls behind the wall. The first of these deeper walls is made of ghostly particles called neutrinos. Neutrinos interact with matter so weakly that they are almost impossible to stop. Trillions of them are passing through your body every second, from the sun, from the ground, from space, and you feel nothing, because they slip through the atoms of your body almost without ever touching one. In the early universe, neutrinos stopped interacting with everything else when the cosmos was only about 1 second old, far earlier than the light broke free. Since that moment, they have been streaming through the universe untouched, and they are still here now, a background of relic neutrinos filling all of space, cooled by the expansion to a temperature of only about 1.95 degrees above absolute zero, even colder than the oldest light. This cosmic neutrino background is a wall from 1 second after the beginning, a snapshot of the universe hundreds of thousands of years earlier than the light we have been studying. I want you to imagine that deeper wall, because it is passing through you as surely as the oldest light is. Drop back to the universe at 1 second old. It is a place of almost inconceivable heat and density, a churning fire of fundamental particles, far too hot for atoms, far too hot even for the light to escape. And in that instant, the neutrinos let go. They stop colliding, and they pour outward in every direction, a flood of ghost particles set free while the universe is still 1 second young. They fly, untouched, through everything that comes after. They fly through the forming of atoms, through the lighting of the first stars, through the assembling of galaxies, through the entire age of the cosmos. And they arrive tonight, right now, sleeting through your body, and through the room, and through the whole earth, a bath of the oldest witnesses there are, colder and older than the light, still carrying the imprint of the universe at 1 second old. You are sitting inside two edges at once, the wall of light and, behind it, the wall of neutrinos, and you cannot feel either. The reason we do not simply point a telescope at this neutrino wall and read it, the way we read the oldest light, is the same reason it survived so pure. Neutrinos barely interact with anything, which means they barely interact with our instruments either. This relic neutrino background has never been directly detected. We know it is there, with great confidence, because its gravity leaves fingerprints on the oldest light and on the way galaxies are arranged, and the numbers come out exactly as the theory of a 1 second old neutrino release predicts. But to catch the neutrinos themselves, to read the wall directly, is at the very frontier of what physics might someday manage. It is an edge we are certain exists and cannot yet look at. And there is a wall, deeper even than the neutrinos, the deepest wall physics can imagine reaching. If the very early universe went through the burst of runaway expansion that many cosmologists believe it did, in the first tiny fraction of the first second, then that event would have shaken space itself and sent out ripples in the fabric of space-time, gravitational waves, from almost the very beginning. Gravitational waves pass through everything, even more freely than neutrinos. They would carry an image of the universe from a moment unimaginably close to the start, long before there were atoms or neutrinos free to roam. This primordial gravitational wave background would be the oldest wall of all, the closest we could ever come to seeing the beginning itself. It has not been detected. Finding it, most likely through a faint twisting pattern it would leave in the oldest light, is one of the great goals of cosmology, because it would be a direct message from the first flicker of existence. It is worth dwelling on just how untouched these relic neutrinos are, because it makes them the purest record we have of the distant past. The oldest light, as clean as it is, was released after 380,000 years of the universe's history had already played out, and it was shaped by everything that happened up to that moment. The neutrinos let go far earlier, when the universe was 1 second old, and they have been coasting freely ever since, essentially unaltered, carrying a fossil imprint of conditions from before the light was even trapped. They are, in a real sense, the oldest thing that still exists in its original state. Everything else, the matter you are made of, the light in the sky, has been reprocessed 1,000 times over. The relic neutrinos have just been falling through empty space for the whole age of the universe, remembering the first second. To catch even one of them and read it would be to hold a message written when the cosmos was younger than a single heartbeat. Physicists have not given up on catching that message, and the attempts show how hard the deeper walls are to reach. There are experiments being designed to try to capture relic neutrinos by having them trigger an incredibly rare reaction in a carefully prepared target, a signal so faint that shielding out every other source of noise is a monumental task. And for the gravitational wave wall, whole telescopes and satellite missions have been built and proposed to hunt for that faint twisting pattern in the oldest light. Once, a team announced they had found it, and for a few weeks it looked as though we had seen the first instant directly, until closer analysis showed the signal was mostly dust in our own galaxy, mimicking the pattern. The true signal, if it is there, is fainter still, and the search goes on. These are the walls we know are there, and strain, at the very limit of our cleverness, to see. Each failed attempt is a reminder that the edge is not a simple thing you look at, but a series of ever older boundaries, each one guarded by how faintly its messenger touches the world. So the single edge we started with has quietly become a nested set of edges, one behind another, each made of a different messenger, and each showing an earlier instant. There is the wall of light, from 380,000 years. Behind it, the wall of neutrinos, from 1 second. And behind that, in theory, the wall of gravitational waves, from the first sliver of the first second. 3 walls, at 3 different depths in time, and here is the point that ties the whole night together. Not one of them is made of matter. Each is made of a messenger and a moment. Each is not a place but a time, wrapped around us as a sphere, at a distance set by how long its messenger has been traveling. We have now seen the edge from every angle, taken it apart completely, and followed it down through 3 layers. So we are finally ready to gather all of it into a single answer. In the next part, we say plainly, at last, what the edge of the universe is truly made of. Part 11. The edge made of time. We have gathered every piece, and now we can see the shape they make together. And the shape is stranger and simpler than the wall we started with. The single deepest truth about the edge of the universe, the one that all the others hang from, is this. The edge is not a place in space. It is a moment in time. Everything we have found tonight is a consequence of that one fact, and once you hold it clearly, the whole thing stops being paradoxical and becomes almost obvious. The edge feels like a distance because telescopes show it to us as a distance. But its true nature is a time, the beginning of things, seen from the inside, wrapped all the way around us. Follow the logic once more, quickly, now that every step is in place. To look far is to look back, because light takes time to arrive. To look as far as possible is to look back as far as possible, to the earliest moment light can carry to us. That earliest moment is the edge. So the edge is not the farthest place. It is the earliest time. The reason it lies in every direction is that the beginning was everywhere, so its light comes to us from all sides at once. The reason it sits so far away is that the light has had the whole age of the universe to travel while space stretched beneath it. And the reason it can never be reached is the deepest reason of all, and it is worth stating as plainly as I can. You cannot travel to the edge because you cannot travel to a moment. The edge is not a where, it is a when, and no journey through space, however long or fast, has ever carried anyone to a time. Think about what that means for the child in the spaceship, flying outward to find the wall. Suppose you really did it. Suppose you climbed into the fastest ship imaginable and flew toward the edge for billions of years. You would never arrive at a wall, and here is why, stated in the language we have built. As you flew, you would pass galaxy after galaxy, and each one would look, to you, ordinary and present day, full of stars living their lives right now. You would never catch up to the past, because the past is not out ahead of you in space. And when you finally stopped, wherever you stopped, and looked around, you would find a brand new edge surrounding you, centered on your new position, exactly as far away as your old edge had been, still made of the oldest light, still the beginning, wrapped around you. You would have traveled billions of light years and gotten precisely nowhere nearer the edge, because the edge was never a destination. It was always the horizon of your own past, and it moves with you, and it stays always the same age of the universe away. This is the moment to return to a phrase I gave you earlier, because it means something new now. I called the surface of last scattering a wall you are standing in the middle of. When I first said it, it meant something spatial, a shell of light surrounding you on all sides, but you can hear it differently now. The wall you are standing in the middle of is not only a wall of light around you in space, it is the beginning of time around you, the first moment of the universe, curved into a sphere with you at its center. You are standing in the middle of the beginning. Every direction you look, past the galaxies, past the reddened early light, you are looking at the birth of everything, and it encloses you completely, because you and everything you can see came out of it, and its light is only now finishing its journey home. Let that be the still point of the whole night, because it is the thing worth carrying away. The edge of the universe is not ahead of you. It is behind you, in time, and it surrounds you on every side, the first moment of everything. Wrapped around you as a sphere, you sit at the center of. To look up at the night sky, past the stars, is to be encircled by the beginning. It is unreachable, not because it is far, though it is unthinkably far, but because it is the past, and no one can walk into the past. The oldest light is a ring of fire from the dawn of time, closed around each of us, always at arm's length in the language of distance, and forever out of reach in the language of time. You are, right now, sitting inside the afterglow of your own origin, and it is falling on your skin as microwaves too faint to feel. There is a quiet consequence in this that reframes even you. If the edge is set by how long light has had to reach you, and by where you happen to be, and by when you happen to exist, then the edge is, in part, made of you. Not you as a substance, but you as a vantage point, a here and a now from which the universe is being observed. Remove the observer, and there is no particular edge anywhere, only the seamless cosmos, boundless and indifferent, with no special sphere drawn in it at all. The edge exists because someone is looking. It is the shape the universe takes when a mind at a particular place and time asks how far it can see. The edge of the universe is partly a fact about the universe, and partly a fact about the one who looks. There is a way this changes how you might feel about distance itself, if you let it. We are used to thinking of far away as a kind of exile, a place remote and disconnected from us. But the farthest thing in the universe, the edge, turns out to be the thing we are most intimately bound to, because it is our own beginning, and it is touching us right now. The nearest star takes years to reach us with its light. The edge takes the whole age of the universe, and yet the edge is closer to you, in a sense, than that star, because the edge is inside the room, passing through you, arriving on your skin this very second, while the star is only a point far off in one direction. The most distant boundary there is also the most present thing there is. That is what it means for an edge to be made of time rather than space. It does not stay away at its distance. It comes home, everywhere, always. And when you remember the walls behind the wall, the whole picture deepens once more. It is not only the beginning of the visible universe that surrounds you. Behind the ring of oldest light is the ring of neutrinos from the universe at 1 second old, and behind that, in theory, the ring of gravitational waves from the first flicker of existence. So you are not encircled by a single moment, but by a nested set of moments, each one earlier than the last, each one a sphere centered on you, the deepest of them, almost touching the very first instant of time. You sit at the center of layer upon layer of the past, each layer a wall made of a different messenger, each one wrapped around you, each one unreachable for the same reason. The whole early history of the universe is stacked around you in concentric shells of time, and you are at the middle of all of them because you are the one who is looking, here, now. To exist and to observe is to be surrounded by every beginning at once. We have, at this point, taken the honest answer almost all the way to its conclusion. But before I say the final words, the plain answer to the plain question, there is a debt to pay, because not everyone accepts any of this. There are people, some of them quite serious, who insist that the edge really is a solid thing, a dome, a wall, a firmament, or that the oldest light is not what scientists say at all. These claims deserve a fair hearing and an honest answer, and giving them one will actually sharpen everything we have said. So in the next part, before we close, we turn to the people who still believe in a wall, and we find out exactly why the evidence does not let us keep one. Part 12. Domes, Firmaments, and Tired Light. The instinct that the sky must have a solid edge is very old and very human, and it is worth taking seriously rather than mocking, because the honest response to it is more interesting than dismissal. For most of human history, people believed the sky was a hard vault, a dome overhead, with the stars fixed to it like lamps hung on the inside of a great ceiling. Some people still hold a version of this, the idea that the heavens are a solid firmament enclosing a flat and bounded world, with the stars set into a nearby shell. It is, in a way, exactly the child's picture of a wall made real and brought close. And the reason it is wrong is not that scientists have decreed it so. The reason it is wrong is that every measurement we can make of the sky contradicts a nearby solid boundary, directly and completely. Consider what a dome, with stars fixed to it, would require. It would mean all the stars sit at roughly the same distance, stuck to a single shell. But we can measure the distances to stars, and they are wildly different. The nearest is a little over 4 light-years away. Others are hundreds, thousands, tens of thousands of light-years off. We measure these distances several independent ways, including by watching a nearby star shift its apparent position against the far background as the Earth moves around the Sun, an effect called parallax that only works because the stars are at genuinely different, enormous distances. There is no shell. The stars are strewn through an enormous depth of space, not painted on a ceiling. A dome cannot survive the first careful measurement of how far anything is. Then there is the oldest light itself, the cosmic microwave background, which some who reject the whole picture try to explain away. The most serious attempt to do so is an idea called tired light, first floated nearly a century ago. It proposes that the redshift we see in distant galaxies is not caused by expanding space at all, but by light slowly losing energy as it crosses great distances, growing tired on the long journey. If that were true, there would be no expansion, perhaps no beginning, and the oldest light would be something other than the relic of a hot young universe. It is a clever idea, and it deserves the respect of being tested rather than waved away. And when it is tested against real data, it fails on several independent fronts at once. The first thing tired light cannot do is reproduce the shape of the oldest light's glow. The cosmic microwave background has the most perfect thermal spectrum ever measured, the exact signature of radiation that came from a hot, dense object at a single temperature. That precise shape is what a hot, early universe naturally produces, and what a gradual energy loss process cannot, because scattering light into tiredness would smear and distort the spectrum rather than preserve its flawless thermal form. The second failure is even more telling. When we watch distant exploding stars, the kind we use as cosmic distance markers, we see their brightening and fading unfold in slow motion, stretched out in time by exactly the factor that expansion predicts. A star explosion that should take a certain number of days appears to take longer, the more distant it is, because the expansion of space stretches not just the light's wavelength, but the very timing of the events. Tired light has no way to slow down time itself. Only genuine expansion does that, and we see it happen, over and over, exactly as predicted. So the picture holds, not because it is fashionable or because it is enforced, but because it survives every test that the alternatives fail. The stars are at different distances, so there is no dome. The oldest light has a perfect thermal glow, and the distant universe runs in visible slow motion, so the expansion is real, and the beginning was hot and dense. Every attempt to put a solid wall at the edge, or to deny that the oldest light is the relic of that beginning, runs straight into measurements that do not allow it. The edge stubbornly refuses to be made of anything you could touch. I want to be fair and clear about what remains genuinely open, because honesty is the whole spirit of this channel, and pretending the picture is perfect would be its own kind of dishonesty. The oldest light does hold a few real puzzles. There is a patch of sky in the direction of the constellation Eridanus that is oddly colder than it should be, nicknamed the cold spot, and no one is entirely sure why. There is a curious alignment among the largest ripples in the oldest light, a pattern that some have half-jokingly called the axis of evil, which appears more organized than random chance would easily explain. These are real anomalies, and they are under active study. But notice what they are and what they are not. They are small statistical oddities in a map that otherwise matches the theory to extraordinary precision, 1 part in 100,000 across the whole sky. They are not evidence of a dome, or a hoax, or a hidden wall. They are the ordinary frontier of a working science, the loose threads that either turn out to be flukes or, occasionally, lead to something new. Real wonder does not need the picture to be perfect. It needs us to tell the difference between the questions that are still open and the answers that are already settled. There is a third test worth mentioning, because it directly checks whether the universe is expanding or static, which is the heart of the disagreement. In an expanding universe, distant galaxies should appear dimmed in a very specific way, their surface brightness falling off far more steeply with distance than it would in a static cosmos, because expansion both stretches the light and spreads out the arrival of the photons. This particular dimming has a precise predicted signature, and when astronomers measure the brightness of galaxies across a wide range of distances, they find exactly the steep fall-off that expansion requires, and that a static, tired light universe cannot produce. It is one more independent line of evidence, measured on ordinary galaxies, all of it pointing the same way. The universe is expanding, the beginning was real, and the oldest light is its relic. There is even a small, elegant clue hidden in the oldest light that points to our own motion, and it is hard to explain any other way. The cosmic microwave background is not perfectly the same in every direction after all. It is very slightly warmer in one particular direction of the sky, and slightly cooler in the opposite direction, by about 1 part in 1,000. The reason is beautifully simple. Our whole solar system is moving through the universe at a few hundred kilometers per second, And as we move, the oldest light ahead of us is shifted slightly warmer and the light behind us slightly cooler, exactly the way the pitch of a passing siren rises and falls. This tiny lopsidedness is precisely what you expect if the oldest light fills all of space and we are drifting through it. It is nearly impossible to explain if the light is some local glow or the inner surface of a nearby dome. The universe left its fingerprints on this light, and they all tell the same story. And with that debt paid, with the wall denied its last defenders, we are finally ready to say the thing this whole night has been building toward. We have looked at the edge from every side, taken it apart, followed it down through its deeper layers, and defended it against the idea that it is solid. Only one thing is left to do, and it is the simplest thing of all. It is to answer, plainly and completely, the question we started with. What is the edge of the universe made of? Part 13. What the edge is made of. So here it is, the plain answer, earned at last. What is the edge of the universe made of? It is made of light and time. Not stone, not glass, not a curtain of nothing, not any material you could name or touch. The edge of the universe is made of the oldest light there is, and the oldest time there is, the two of them together, and nothing else. Everything we found tonight was a way of arriving at that single sentence, and now that we are here, we can see all of what it means. Start with the light, because that is the part you can actually point to. The visible edge, the boundary real telescopes reach, is the surface of last scattering, the moment the universe turned transparent and released the light that had been trapped inside it. That light has been traveling for more than 13 billion years and is arriving at us now, stretched by the expansion of space into a faint microwave glow that fills the whole sky in every direction. When you ask what the visible edge is made of, that is the honest answer. It is made of the oldest light in existence, the cooled fire of the newborn universe, the last flash of the fog before it lifted. It is not a wall that light bounces off. It is the light itself, the final message of the beginning, still on its way in. Now the time, because that is the deeper half, the half that dissolves the question. The edge sits where it sits, and behaves as it does, because it is not really a place at all. It is a moment, the early universe, seen from inside, wrapped around us as a sphere. To look toward the edge is to look backward into the past, and the edge is simply the earliest instant that any light can carry to us. That is why it lies in every direction at once, because the beginning was everywhere. That is why it is more than 46 billion light-years away, because the light has crossed an expanding space for the whole age of the cosmos. That is why it can never be reached, because it is not a where but a when, and no one can travel to a when. And that is why it is slowly closing, because it is made of time, and time can be carried away by the stretching of space. The edge is made of time in the most literal sense. It is the boundary of the past, and it is drawn by the age of the universe, and the speed at which cause and effect can travel, which are the only two ingredients the universe ever uses to draw an edge. And there is that last, quiet turn, the one that includes you, in the answer. The edge is not only made of light and time out there in the cosmos, it is made in part of you, of the fact that there is an observer here, at this place, in this moment, asking how far the universe can be seen. The particular sphere that is your edge is set by where you stand and when you exist and how long light has had to reach you specifically. Someone else, somewhere else, has a different edge, centered on them. Remove every observer, and there is no edge anywhere, only the boundless cosmos, with no line drawn in it. The edge comes into being because someone looks. So the full answer, the complete answer, is that the edge of the universe is made of light and time, and the one who is looking. It is the beginning of everything, seen from a particular here and now, curved into a sphere with a watcher at its center. Think, one last time, of the child in the spaceship, flying out to find the wall at the end of everything. There is no wall. There was never going to be a wall. If that child flew forever, they would only ever be surrounded by more universe, and by the same ring of oldest light, hanging always at the same distance, the beginning wrapped around them, wherever they went. What they were really looking for was not out ahead of them in space. It was behind them, in time, and it was already touching them, falling on them, as a faint microwave glow from every direction, the whole way. The edge they wanted to reach was the moment they came from, and you cannot fly to the moment you came from. You can only carry it with you, as everyone does, encircled by their own beginning, at the center of their own sphere of ancient light. I said at the very start that the answer would be stranger and quieter and more beautiful than any wall, and I hope now you can feel why. A wall would have been an ending, a hard stop, a place where the universe simply quit. What we found instead is that the universe has no ending like that anywhere, only a horizon of sight, and behind the horizon, more cosmos, and around each of us, the soft light of our own origin, arriving late, forever. The edge of the universe is not the place where everything stops. It is the place where our seeing stops, and it is made of the oldest light and the oldest time, wrapped gently around every watcher who ever looks up and wonders. It is worth saying once more, slowly, because it is the kind of thing that only settles if you let it land twice. Everything you have ever seen, you have seen late, and the farther a thing is, the later you see it, until at the very limit, you are seeing the earliest thing there is. That limit is the edge. It is made of light, because the oldest light is what reaches you from it. It is made of time, because it is nothing more than the earliest moment light can carry. And it is unreachable, not out of some technical difficulty, but because it is the past, and the past is the one country no ship has ever sailed to. When I told you earlier that you cannot travel to a when, that was the whole answer in disguise, waiting for the rest of the night to make it clear. You cannot travel to the edge for exactly the reason you cannot travel to yesterday, because they are the same kind of thing, and the edge you are standing in the middle of is not one wall but many, nested, each older than the last. The light from 380,000 years, and behind it the neutrinos from 1 second, and behind them, waiting to be read, the tremors of the very first instant, layer upon layer of the past, each a sphere around you, the deepest of them almost brushing the beginning of time itself. You are not merely near the origin of the universe. You are surrounded by it, on every side, at every depth, and it is arriving at you constantly, a soft and endless rain of the oldest light and the oldest time, falling through the dark room while you rest. That is what the edge is made of. That is what has been around you your whole life, closer than any star, quieter than any wall. There is one thread left loose, and I will leave it loose, because it is the right way to end. Behind the wall of light are the deeper walls we cannot yet see, the wall of neutrinos from the universe, at 1 second old, and beyond it, perhaps, the wall of gravitational waves from the first flicker of time. We know they are there. We have not yet learned to read them. Somewhere in them is written what the universe was doing before the light broke free, in the moments we have never seen, and there will come a far-off age when the expansion has carried even the oldest light away, and no one left will be able to see any edge at all. We are here in the narrow window, when the beginning is still legible, still glowing softly, all around us, still close enough to touch us on the skin. So tonight, before you drift off, you can hold the strangest and gentlest fact there is. The edge of the universe is not far away. It is here, in the room, passing through you, the light of the first morning, still arriving. Rest easy. You are lying in the middle of the beginning, and it has been keeping you company the whole time.